Man, what is this book?
Welcome back to this episode of Three Ball Math Guys. In this episode, this show, we are looking at any of those math memes that are out there, and we're going to try to see what it is that they mean. Meme. Here we go, this week on Three Ball Math Guys. Well, yeah, well, that was a great intro. I didn't know that meme and mean sound the same thing. Mean, meme. All right. Okay, so there we go. So we've got our resident three-ball math guys here. We got Professor Detson. Hey, there he is. Look at it. Look at that guy. There he And over on this the other clown, Professor Jordan, right there. 3-time defending Jeopardy champion, but 0-time defending champion in the other one.
Mathergories.
Mathergories.
I got whooped.
Yes. Yeah, take that. Yep. All right, so we are doing math memes this show, and our producer, Professor Michael, we'll dub him Professor Michael.
Oh, yeah.
In this one, because he came up with these. Oh, he's thinking, yes, give me the paper for that one.
Pretty proud of himself over there behind the computer monitor.
It's our show. It's our rules. Okay, so we've got all these math memes that we're going to be taking a look at, and we're going to try to see if we can come up with what they meme.
Okay, here we go. So again, I don't know what most of these mean or say, so I'm hoping you guys do. Are you guys ready for this?
We're ready. Ready.
Put it up
Here's
there.
the first one.
Oh, I got it.
Maths be like you are.
That's an acute. That's T, and that's pie.
Oh.
Maths be like, you are a cutie pie. Cutie pie.
Okay. A cutie pie.
Acute angle, glass of tea, and then the symbol for pie.
Nice.
Oh, that's a good one.
Yeah.
Okay. 1 for 1, maybe.
1 for 1.
Assuming that was right.
That wasn't too bad.
Right.
Yeah.
That was. It's pretty easy.
Okay.
I didn't get the T, though. Didn't look like tea.
Looked like some British tea.
Yeah.
All right, mate.
Well,
All right. Here's your next
it
one.
wasn't Thai tea, so I didn't recognize it.
Maths teacher when you get a question wrong. Maths teacher when they get a question wrong.
What do you guys do when you get something wrong?
Blush a little bit there.
Yeah.
And,
When our students get something wrong, yeah.
yep, when the
after
students
them.
get it wrong, then they get a mouthful there.
I've had some of those moments in my office. Like,
Well, SpongeBob takes care of that pretty well right there.
Yeah.
Good job.
Proving to not be as easy as we want. Okay, here we go. Next one.
Students, I'll never use Pythagoras theorem in real life. And then it starred also students walking home.
So can we explain that? What does that mean?
Pythagorean theorem is based on the right triangle, and the hypotenuse is always going to be the length of the longest side. And so for this one, it looks like they're basically taking that shortcut instead of going on the legs, which would be the two sides that make up the right angle, that create the right angle. They're taking the shortcut there. But now you might say, okay, well, that's the longest side. But if you take a look at the two lengths of the legs and add those two together, it's going to be longer than the length of the hypotenuse, so which is the triangle inequality theorem.
Yeah.
So you've got a whole bunch of stuff going on there. Woo.
Yeah, it's less Pythagorean theorem and more just
Common
shortcut.
sense.
Yeah,
Shortcut.
Shortcut.
Yeah. They're using it, but they don't know they are.
Good.
So Professor Michael, just on a random day, you say, I'm going to look up some math memes.
Pretty much, yeah. And I understood like 2 of these maybe. We'll cut this out.
All right. So while Professor Michael's taking care of that, so do you guys go through that same thing where you, like, if you're walking to your office from a meeting somewhere else or wherever, it doesn't have to be to your office, And you say, well, if I take this little shortcut, I'm going to cut down my distance that I have to walk.
I'll go first. Mine is all weather dependent. If it's nice outside and I want to walk outside, if it's hot outside and I want to walk in the cool inside, if it's cold outside and I want to walk in the heat, yeah. Less distance dependent and more temperature dependent.
Okay.
Yeah,
Jim-
for me, looks like I need to get some more steps. So usually I was like, which one's going to give me more steps? You know, at least this is the only time I'm out walking, so I like to get some more steps in. So yeah, that does play a role. But speaking of this, I'm going to go on a tangent a little bit. Coming here today, I was thinking, you know, everyone's like, I don't ever use math for anything, right? But if you're trying to get to a place at a certain time, you're always thinking about the time and how far you have to go. So how much time you got to give yourself to get up, to get ready, to be at a certain place. Everyone does that every day. So, I mean, you're using math every day, even though those that say they don't use math, just like the fellow there using the hypotenuse shortcut, he didn't even know he did it. So,
Yeah.
Yeah.
mathematics.
And you're
everywhere.
after more
Every day.
steps, so you would have stayed on that sidewalk.
Yes, yes. And I knew Professor Jordan was going to be a little late today, so we took a scenic route instead of going the shortest path to get here today.
Look at you.
I was just thinking about that. Very
Yeah.
good.
You and your culture. Let's see the culture route today. Okay, here we go.
Here's the next one.
Oh boy.
Ooh. So a girl, when I ask her out, is on the left. A mathematician, if I ask for the derivative of e, blah, 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 that x equaled 1 over w.
Does that make any sense at all?
Well, I think it's ew.
Ew.
Like ew, David. That's definitely happened when I asked girls out in the past. What's the derivative of e to the what is x? What's that w?
They didn't just give you a fake number like 867-5309, because that's usually what happens when I ask the girl out.
They're less polite to me. They just ew right in your face. No. So that derivative must be equal to ew.
EW, yeah.
Okay.
Yeah, we could figure that out.
I don't got my calculus hat on quite
Yeah.
yet.
Oh, he took it away.
Oh, we're
So it's
still reading?
w e to the xw. And then he took at x equal, there it is, at x equal 1 over w. So yeah, w e to the xw would be that derivative, because that's the indestructible function. W e to the xw evaluated at x equal to 1 over w, so substitute that in. You get x to the first. That's ew, EW. Yes, that is correct. So the math is right.
The math
Now,
is
the calculus is right.
maths on that one.
Did you just do the integral?
Yeah,
though?
yeah. Show them your work on that.
No, that's the derivative.
Oh, okay. Okay. I
Well,
saw you.
I use the
I saw
symbols.
you're evaluated
Yeah.
at.
So in English terms, what is that?
It just says
Ew.
It says
Ew.
ew. It's a funny way to say ew.
Yeah,
Okay.
it's just a mathematical way to make ew.
There you go.
Okay, there we go.
Yeah. Yeah, the derivative of e to the xw is w e to the xw. And then when you evaluate it, x equal
1 over
to, yeah.
1 over w, they cross out, and then
We're
you get
left
E
with
to the
W.
first, yeah.
Ew.
W
Perfect.
times e. Ew.
Very good.
Ew.
All right, it's gonna be kind of small, but can you read that?
So it says me, square root of x squared equals x. My math teacher, and it's an orangutan, just sitting there.
Very happy.
Yes.
So what does this mean?
I mean, your guys' guess is as good as mine. That guy looks.
I don't know if he's happy or he's
He's just looking.
like, there's more up my sleeve. You know,
So what does that math equation mean then?
Well, square root of x squared equals
Yeah.
x. Would it not equal also negative x or not?
It could equal.
Because if you square
Yeah.
negative x, you get also x squared. Yeah, math people.
That's
Yeah.
why
People in the
looking
room?
at his face, is he saying,
He's-
is he happy or is
He's
he
saying kind
There's
of.
got to be
you're
more to
almost
this.
there?
You're pretty much right. But there's more to this story. Maybe there's more to this story.
Do we need to define X still? I
Yeah.
mean, there's a lot to it.
There's a lot to it.
I think he's thinking a lot right now. How much do I want to blow this reporter's brain? Because I could really blow his brain.
Alright. Next. What does that mean?
So sine x and cosine x meet for the first time, and then they meet up with this other guy and got the number 1.
So is that like playing off the trig identity function?
That's what I'm thinking of, trig identity. But those are squared though,
Right.
so I don't know if that would be it.
Is there anything on the guy with the orange shirt?
Sine squared plus cosine squared
Equals 1.
Equals
equals
one.
1. So minus sine squared equals cosine squared. So those two disappeared and we're left with 1. I don't know.
It is a play on that trig identity though.
I'm stumped.
Tricky one.
I mean,
Yeah.
611,000 people liked it, so must be smarter than 3 bald math guys.
I guess so.
And that'll happen.
Enter SpongeBob blushing.
Well, I've seen this one already, so you guys can figure this one out. So how it feels talking to someone whose b squared is less than 4ac.
Absolutely. This is from the discriminant,
The
of the
discriminant.
quadratic formula.
Yeah.
If b squared is less than 4ac, she will be imaginary.
Imaginary.
Good job.
Yeah.
You guys are pretty smart.
Because used in the quadratic formula underneath the
square root,
radical.
yeah.
Yeah, it's a square root. And so if 4ac is greater than b squared, then you can't, the square root of a negative number would be an imaginary number.
Okay.
You guys are so smart.
Yeah. I feel way smarter than that trig identity one.
Although I think we're right with the trig identity one. I think the meme was wrong by saying it's sine x and cosine x meet each other. It should be sine squared x and cosine squared x meet each other. The meme is wrong. We are not.
That's our rules.
Our rules.
Our show.
This is our show.
3 bald math guys cannot be wrong.
If you think we're wrong, let us know.
Absolutely.
Make sure to explain your answer.
Yeah, explain your answer.
Okay.
We explain everything here.
Here's this one. Math be like.
Is that a triangle?
Yes, obviously.
Oh, really? Prove it.
Oh, you see, if you have these things called eyes, you can see that it's a triangle because it has 3 sides.
Ha! No. Prove it using this. Man, what is this bull? Is that a triangle?
That's a funny one.
That is
Yes,
a funny one.
obviously.
I think that one's playing off of geometric proofs, 2-column proofs.
Yeah, making fun of them.
That or something as simple as you could see it with your eyes. Why do I need to prove it? One of those things where, like, you got to show your work, you know?
Oh, yeah.
And students are like, why do I have to show my work? I know that's the answer. So that's I think that's kind of what that one is.
Yeah.
It's a triangle. You could see. You could tell. No, prove it.
It's like the one that says, my teacher asked me to find X. Here it is.
Yeah, exactly.
This is a triangle. There it is.
Yeah, that's a triangle.
Okay, we got 2 more.
All right, 2
All
more.
right,
Here we
here
go.
we go.
Let's knock them out.
And 2 plus 2 equals?
4.
4. Correct. And this brings us to our next point in the segment. And that concludes our lesson.
That's pretty spot on. Sometimes when you're talking and your students are just kind of dozing off, and then all of a sudden you have talked about stuff that is going to be on the test, and they have no clue.
And I bet it moves that fast sometimes.
So seeing that meme, what do you guys do when there's a student that falls asleep in your class?
Ooh. I've done a couple different things. I've rudely woken them up by like dropping a book right next to them or something like that. Depending on the relationship and how big the class is, sometimes I've had a whole class get up and walk out of the classroom and scare them that way. I've done that one before too. That one's really fun. But you have to kind of know the student. They have to have a good sense of humor to do that. What do you guys do?
Yeah, I've done the same thing as far as dropping a book or a pen or a pencil or something like that, not making a lot of noise. Other things I've done too is kind of is get the whole entire class up, not send them out of the room, but surround that student.
Oh, jeez.
And then once they
Just
Yeah.
standing on top of
just
them.
kind of hovered over the top of them, and then they get pretty startled when they realize that.
I mean, a little doze off is okay, but I've had a student snoring in the classroom, so I just tell my students, just leave them alone, let them sleep. Class is over, and still sitting there snoring. Go tap them on the shoulder. Hey, class is over. Homework, whatever is due. Oh,
Sorry about that.
Okay. All right. Here we go. Last one. This one I'm really curious. This is
All
what
right.
I've been waiting for. So, this was just a picture.
Me peeling potatoes and my mom peeling potatoes. So we got the summation of f of x k times delta x, and we have the antiderivative of f of x dx as we go from a to b.
I'm just cheating off of the comments here.
So yeah, one is a definite, and one is a discrete random variable. The other one is a continuous random variable.
So in English, what does that mean?
One makes it look a heck of a lot easier than the other one.
Oh.
I mean, in the simplest way that I can kind of describe it. One is a long, drawn out way. The other one is a quicker way. Am I accurate there?
so the summations, basically, you're just counting and adding. Mm-hmm. So, and then the other one's an integral, calculus. As that comment says, I mean, I think that comment is spot on. One is simpler, and the other is more refined, if you will.
Yeah. Be like putting a difference quotient up there and derivative.
For the limit?
Yeah.
Yeah.
Yeah,
Yes.
both of them are kind of expected values, mu. And so yeah, you could look at it that way. Finding areas. On the left side, you're looking at piecewise, and on the right side, you're looking at it with the entire length from A to B. Yeah,
So if it's me peeling potatoes, I'm chunking off pieces, and my mom's just going.
yeah.
There you go.
Okay. That makes sense.
So that's kind of an interesting one. Yeah.
Yeah, I mean, you definitely have to have a mathematical mind to
Peel
be
potatoes.
able to understand that one. Obviously, to peel potatoes too.
Well, good job, Professor Michael. That's
you.
a good job with all those math memes. I'm sure there's some other stuff out there that you're going to find later on for us to be able to have another show about. But that is this episode of Three Bald Math Guys. See you next time.